stupid. Hey guys, welcome back to another episode of V Builds. In the last episode, I showed you how to use a spot welder. That was the first step in our electric bike build. Next step is we are going to build a battery. According to my plan, this tank will contain the battery. So I'll have to make the battery in such a way that it can be fixed inside this tank. These are the things that you need. These are lithium-ion cells. One cell is 1200 mAh and 3.7 volts. You can get these in different configurations. So I got 2 packs of these. So these are total 200 cells. And then I'll talk about these in a bit. But then there are these connectors which are used to connect the cells. They give a specific spacing between the cells, which is very important for the safety. Then is this nickel strip which we will be using to connect. And the last one is the BMS. So here the battery management system, here I am using a 3.7 volt 13S 20 amperes BMS. So here is everything. Let's cut it. I hope you got the idea. Basically what I'm going to do is cut it like this. Okay, install a hinge here so that I can just flip it open from here, because I don't want to make the cuts on the sides or the top because it will destroy the look of our bike. Now is the time to show you what's inside a bullet fuel tank. Safety first. There you go, it's all cut. Wanna see what's inside? Hey, surprise. Okay, I show you. Fuck, you ruined the surprise. Ta-da! I will place a battery inside this. Let's talk about the cells again. So these are, as I said, lithium-ion cells. These come in various configurations, but the tricky part is to identify if these are genuine or not. Like you might get one for, this is for 1200 mAh, you might get one for 2600 mAh, 3000 mAh, even 6000 mAh. But just make sure it is what it says. Usually the 1200 mAh is the genuine cell, and any other cell in this configuration, it is very rare to find them genuine. You can check the weight. The heavier it is, the cell is, the more mAh it has. So when you compare, sometimes you'll see that the 2600 mAh cell is lighter than the 1200 mAh. That means it is a fake and you need to stay away from those. So that's how you identify the genuine cells. Now, how we connect the cells to make the battery is, there are 2 types of connections, series and parallel. Now this is the positive end and this is the negative end. Then if you are connecting them in series, you have to connect the positive terminal with the negative terminal, like this, positive with the negative, and then you have to take the output from one of the negative and one of the positive. So this will combine the voltage. So this is 3.7 combined in series, it will become 7.4 volts, right? And in case you want to increase the capacity, in that case you just connect them in parallel. That would be positive with positive and negative with negative, like this. And in that case, this 1200 mAh will become 2400 mAh, but the voltage will remain the same. So we need to use these combinations to make the battery of the size that we want, the ampere and the voltage that we want. I'm going to build a battery for 48 volt, around 50, let's say, and 1.5 ampere. So this fuel neck is obviously taking a lot of unnecessary space, so let's chop it off. So now I have seen the inside of our bullet where we need to place the battery. So I'll be making small blocks of 3 into 6 pieces of batteries and then place them inside the fuel tank. That's how I will know what exactly will be the structure of my battery, and then I will make the battery. I need one here. I need 13 by 15. The number 15 is like negotiable, but 13 is fixed because 13 series will make 48 volts and 15 parallel will make the power of the battery, like how much ampere do I need. So this is 6, pair of 6, pair of 6, and this one. So this is 13. And now 1, 2, 3. So we need 12 more. I just need to check the length and height. This is the final structure of how the battery is going to look like. This is in a U shape, and I am making it in such a way so that it fits the bullet tank, because it has this tunnel which will be used to connect with the chassis. So this U shape can go in, cover up the tunnel from upside down. Let me show you how. Like that. Okay, that's the plan. Last check if you can close it. Yep, you can close it, and there's enough space left. This is the nickel strip that I'll be using. First I'll be making the parallel connections, and then I'll make the series ones. So I'll start like this. This is the positive terminal. One. I burned through 2 of these spot welders, and trust me, they are not cheap. So make sure you check out my other video where I show you how to use a spot welder, and there's a pro tip at the end which will save you from burning like me. Eventually I ended up using this transformer which converts the 220 volts into 5 volts and gives high current, and I was able to successfully do all the welds. Just that it gets hot after some time and then you'll need to give it a rest, but yeah, it doesn't burn. So I have welded one strip across the battery. This is a parallel connection, all positives. So let's see if all the cells are connected or not. Oops, looks like the first connection itself is not connected. First two cells are not connected. This is okay. So yeah, all the cells are connected except the first two. So let's weld another one here. Yep. So this paper is to keep the cells a bit apart and safe. So I'll be cutting some strips and then placing them between the cells so that they don't, when they are hot, they don't come in contact and everything is safe. So let me cut it. This right here is a thermal tape, it's not a normal tape. I'll just fold this and use this thermal tape. I have made all the parallel connections here on one side of the battery. So parallel connection means, see, the positive end of one cell is connected to the positive end of other, and same way when I connect on the lower side, I'll connect the negative to negative. Same here. So the cells are flipped, all the positive ends are connected, all the negative ends are connected here, then positive, then negative, like that. So this is parallel connection. Now I am going to make the series connection on this side, and then I'll flip it and make rest of the connections on the back of it. Now I'll cut small pieces to make the vertical connections. Let's do this. I'll take some size here. Much should be enough. Here are some pieces for the series connections. So let's make some. Here is our welder. Ta-da! So I have made two connections here, which I feel is enough because I don't want to fall short of this nickel strip. But yeah, this should be enough. Otherwise, if you want more, you can just connect these also. Doesn't matter, but I'll just connect the alternate ones. Now this is a series connection because you see this is positive terminal and this is negative. So let me explain a bit more. Let's say this is 1000 mAh, 15 cells in this row, so it will make 1.5 milliamperes. 1.5 amperes. But let's say it is 3 volts for easy calculation. 3 plus 3 will be 6 volts. Here it will be 9 volts, and then if we keep connecting positive negative, it will keep on increasing the voltage, and down here after 13 cells it will be 39 volts. So basically I took 3 volts, but it is 3.7, so it total makes 48.1 volt, and the capacity it is 1200 mAh, so total it makes 1.8 ampere. So that's what the capacity of this battery is. Let me make other series connections now. I have made the series connection for this side, the right side, and my spot welder is really hot, so I'm going to work on this for some time, and then later I'll weld this side. The right side of the battery can be folded like this, exactly as I planned, right there. So you see, I have to carefully place it over here so that I don't break any welds. Right there, it's perfect. Yeah, that's how it will be, and same we will do for the left side as well later. So if I flip the bottom side of the battery as it was before, the other negative terminals will come right here, right? So I need to connect these to those. So for that I'll be using a copper wire, which is a good conductor, so I'll have to solder some parts of it. One set of connections are complete. Now I just need to connect these, and then the battery will be, oh yeah, then I'll connect the BMS and the battery will be ready. Let's go. These are the wires coming from the bottom line of cells. I'll just paste them on the same lines from where it is coming, so just chip it off a bit. all I need to do is connect the BMS. Before that, let me show you the voltage. Put the multimeter to 200. I hope you can see it. Now negative goes here and positive goes. There you have it. It is giving 50.3 volts. That's a good sign. Okay, now let's connect the BMS. So the difficult part of the battery is complete, these spot weldings. Now whenever these are open, like you can see the bare metal, be very careful. If you short any of these two, it can create a fire. So now the battery is in U shape. These are all the terminals from one side, and the other terminals are on this here, like at the bottom of this and the top of this, so somewhere here. Now we need to connect the BMS. How to connect this is a bit complex, so let me explain. In the BMS, this is a heat sensor. Right here, you just place it somewhere, anywhere in the battery. So I'll just maybe put it inside right there and just place it like that. Then C minus is the negative for charging, P minus is the negative for power, that goes to the motor, B minus is the negative for battery. Now we have these these wires. These are 14 wires. I don't want to connect it right now, but I'll just show you like this. It can be connected. Now this red obviously goes to the positive of the battery, black goes to the negative of the battery. These are quite simple. So positive of my battery is the negative of my battery, and the positive is somewhere here. So I'll just connect them like that. And then here's the complex part. So after the first, let's say you connected the negative here, after this the first wire will go to the positive of this cell down there, okay, and the second wire will go to this terminal here, positive. So this is in a series connection, right? So the bottom two are connected, so one wire goes there, the next wire goes up here, then the next wire goes down here, then the next wire goes here, and like that we just keep on connecting, and finally the positive wire goes there. So this is how you connect the BMS. Let me just do it. I made the connections once more. Do not get confused, since this I have flipped upside down. If I flip it that way, these are the other terminals of the battery. So starting from one goes here, second one goes down there, third wire, then fourth wire, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, and last positive 14. This is how the connections are made. Now I can wrap it back up. Do some more packing. Just before that, let's try on the bullet tank. Is it going in? Come. Oh, perfect, awesome. Not anymore. Yeah. And also the voltage. Let's check the voltage after connecting this. Polarities are really important in this. Let's see if everything is connected on the BMS. We got 50 volts, awesome. 42. Yeah, everything looks cool. Now, all the connections that are left is battery negative goes here, power negative goes here, and charger negative goes here. So let's do that. So So it was not giving voltage as I was expecting. So I found there's a key here. So I am going to connect two wires on this. So hopefully this will turn on. So my BMS is not giving the voltage as I'm expecting. So I've shorted the switch. It's a tongue twister. Okay, so let's see. The key is on. Okay, yeah. Now you see, if I connect one end to the positive and other end to the battery negative, it gives me how much? Oh, it's not this one. It gives me 50.6 volts. But when I connect same to the power negative, it doesn't give me anything. It just gives 0.02. So this BMS is not activated. I have done some research. Let me try to test that if it works. Here's the charger that I got for my bike. It's 59 volt and 2.7 ampere, or let's say 3 ampere charger. First thing, I need to check which one is positive and which one is negative. Okay, so this is positive, this is negative, and it's written over here as well. It says positive and negative. Disconnected the key and then connected the charger and it started charging. Awesome. And now let's see this. This is voltmeter kind of thing. It shows how much battery we have. So let's see. Should be an easy install. I can just connect this to the positive and this one goes to the negative. I hope it doesn't burst. Let's see. Check this out. It shows me how much battery is there. So I can now wrap it up. The battery is finished. Now I'll just connect the P minus, that's the power output, and I will be done. Cool. This heat sensor is gonna go right in there. Do you see? This is the heat sensor going inside. Okay, and the BMS, I'm going to place it here like this. Battery is ready. Here is the positive terminal, and then this one is the charger negative, and this one is the power negative, and I have wrapped it, and the BMS is on somewhere here. All good. Let's try to fix it on the tank. Perfect. Awesome. That a big milestone. The battery is complete, and now I can move on to connecting the motor and try to run it for the first time. So check that out in the next video and keep watching this build. Bye bye. I forgot to mention there are 2-3 things you get to know only when you do it, so I'm going to share that with you. The BMS, once connected, you need to activate that. So there are 2 ways to do that. One is to short, as I must have shown in the video. You need to short the P minus to C minus. No, P minus to B minus. Yeah, P minus to B minus. So P minus is the output and B minus is the battery negative. So you need to short it for like few seconds, and also then you might have to put it to charge to activate the BMS. This is, you know, a secret that I found out with a lot of difficulties. So that's a quick tip for you. Bye bye.
If you like this video, please consider subscribing.